Now here we have bus and memory transfer. What is the bus? How transfer takes place between bus to registers, register to the bus. Okay, so how bus is going to be helpful to transfer the information from the one place to another place. And again, we see that how transfer takes place in case of memory. So memory transfer means either you are going to obtain the information from the memory, so that is called as the read operation, or you are going to write the information in the memory, that is called as the write operation. Okay. So here, let's start with what is the bus transfer. And before this, we have already separate lecture for the register transfer and register transfer language. Okay. And for the basic computer systems, how that computer organization, design, and architectures are different. That discussion was there. You can watch there. And still, if you didn't subscribe our channel, so subscribe it and watch the video again to improve your information as well as share with your friends. Okay. So let's start. So I welcome you all here in this lecture, bus and memory transfer. So bus is what? It is the collection of the path with the help of wires. So it is going to provide the paths which are in group of wires over which we are going to transfer the information from the source to the several destinations. So we can have several source, we can have several destination. So same bus can be also utilized. Later we'll have data bus, address bus. These things terms are going to come. So bus means it is the collection of wires, group of wires. So here when we have transfer takes place from register to bus, so C to bus, bus to R1. And again, if bus is now to the existing system, so then it is transfer is C to R1 direct, like this transfer also we can do. Otherwise, we have transfer here, information is first transferred to the bus. Okay. Then from the in the first situation, what we are saying, what is the contents of C? It is given to the bus. Again, from bus, it is given to the register R1. But it is also possible that directly we can transfer the information from the C to R1. And R suffix followed by decimal that we are using generally for what? If that registers are handled by the processors, means at live it is being utilized. So whenever we are seeking some information, that processor is going to utilize those registers. So now here we have to see how many multiplexers we have to use and what will be the size of the multiplexer. So if you have n bits in a registers, if register having n bits, then we have to use the n multiplexer. And what will be the size of the multiplexers? If you have k registers, then size of the multiplexer is k cross 1. So multiplexer, you already know that it will give always single output, okay, for the to the power n inputs. So when we have multiplexer size like this to the power n cross 1, so this n is going to represent the number of selection lines. So here we have taken the example. So in this example, we have taken 4 registers. So those registers are represented here A, B, C, D. So how many registers here we have? So now here we have 4 registers. So 4 registers. That means how many multiplexer is required? How many multiplexer will be required? 4 multiplexer is required. Now each register having how many bits of information? Each register has how many information? So if you have n bits, okay. So here, so might have this is gone a little down. So here we have 4 registers, okay. And how many each register having how many bits? We have 4 bits. So how many bits are there? That is going to decide the number of multiplexer. So we have 4 bits each registers. So we are going to use the 4 multiplexers and we have 4 registers. So that's why size of the multiplexer is 4 cross 1. Okay. So later it will be much clear. So now here, what we are seeing that we have four multiplexers. Why we have four multiplexers? Since we have 4 bits of information in each register. And so here 4 bits of information, so 4 multiplexers. So that is represented by mux 0, mux 1, mux 2 and mux 3. Now, how many registers we have? 4 registers. Yes. Okay. So bit having 4. So on the basis of that, we have decided how many multiplexers. Now here we have 4 registers. So on the basis of that, we are going to decide how many inputs will be there. What will be the size of multiplexers? So we have 4 registers. So size of the multiplexer is 4 cross 1. That it has 4 inputs. So now LSB of each register, that data is connected to the mux 0. Next bit A1 is connected to the mux 1. Similarly for A1, B1, C1, D1 will be connected to mux 1. And again A2, B2, C2 and D2 will be connected to the mux 2. And A3, B3, C3, D4 is connected to the mux 3. Okay. So this is the connections. And now since size is 4 cross 1, that is to the power 2 cross 1. So number of selections lines is how many? 2. So that is here S0, S1. So same selections lines are connected together to all multiplexers and each multiplexer having single output. So total we have 4 outputs here. So that is the common bus that is having 4 lines. So you have 4 wires. So these 4 wires are grouped together. That is the call as the bus. Okay. Now how transfer will take place, that we are going to see. So in case of multiplexer, you know that if you have 2 selection lines. So in case of 2 selection lines, well, how many combinations possible? 0, 0, 0, 1, 1, 0, 1, 1. So when we have 0, 0 selection line, so it is going to select the first, or here you can say that as per the number, it is given 0, 1, 2, 3. So that 0th input of each multiplexer will be selected when we have selection line as the 0, 0. Okay, which input? 0th. Since it's starting the counting 0, 1, 2, 3. Okay, or you can say that first input. So better we have written here 0. So we'll write the 0th inputs of each multiplexer is selected. Now if you see that 0th input of each multiplexer is what? A0, A1, A2, and here what we'll have? A3. So finally, all contents of the register A is being transferred to the bus. From register A, it is being transferred to the bus. So that is written here. If you have selection line as the 0, 0, then 0 inputs of all mux are selected. So that's why it's going to receive the contents of register A, and which is going to be hand over to the bus. And next, when we have combination of selection line as the 0, 0, then what will happen? First input, okay, which is number as the 1, will be selected. So finally 1 is what? That is for the register B. Okay, here we have B0, B1, B2, and this will be B3. So finally contents of the register B is going to be selected by the multiplexer and it is thrown on the bus. Okay. So again here, if you have, so this is going to be the first one. And again, now if selection line combination is 1, 0, that is going to choose the second. Second means what is the numbering here? 2. So finally 2 is for what? C0, C1, C2, and this will be C3. So the contents of the register C is selected now and thrown to the bus. So now when we have 1, 1, so again, now in this case, third input, which is numbered as 3, will be selected by the multiplexer and it is thrown to the bus. So this 3 is connected to the register D. So each multiplexer's third input is the input of the register D. So like this, it is able to transfer the information from the register to the bus. And similarly here in the symbolic way representation in the block, we can see so directly like this. Register A information is transferred to bus, register B is to the bus, C to bus and D to bus. Okay. So this, and in between what we have, that is the multiplexer, and we have shown in this format. So 0 0 means, so here main important thing is here you have to decide how many multiplexers we are going to use. So number of the multiplexer is being decided by number of inputs in each register. And size of the multiplexer is being decided by the number of register. Okay. So that confusion should not come. N is the bits of the registers. So on the basis of N, we are going to decide how many multiplexers, and on the basis of registers, how many registers are there, we are going to decide the size of the multiplexer. Okay. And 0 0, zeroth input of multiplexer, 0 1 first inputs, 1 0 second, 1 1 means third input of the multiplexer is being thrown to the bus. So one by one, register A, register B, register C, register D, information is being transferred to the bus. So here, how this is the transfer from the bus to register. We have seen earlier. Okay. So here again, from bus to register. Earlier we have seen register to bus. So here we have situation where information is being transferred from the bus to registers. So this bus, this lane, you see that in the lane will have different colors. So these colors codings are important in the lane wire. So on the basis of that, so when they're going to press this connection, if you see that in the lab when they used to make this connection before connecting to the systems. So here each line here will have single wires. Okay. So that is responsible to transfer the information. So this is also collection of the wires. So this is also called as the bus, one of the example of the bus. So now we'll have, any doubt is there, you can write in the comments. Okay. So now next we have how to transfer the information from the bus to register. So here if you see that 4 registers are taken, R0, R1, R2, R3. And here with the help of decoder, again, what will be the size of the decoder? All these things discussion is there. So here, since we have 4 registers, so that's why here we have output of the decoder is what here 4. Okay. So decoder, you know that that is given as the n cross to the power n. So n is the number of inputs and to the power n is the number of outputs. So here two inputs are taken. So size of the decoder is 2 cross to the power 2. That is what? 2 cross 4. So don't get confused about multiplexers and decoder. Okay. So here what you see that we have here Z and W. These are the two inputs here. How it is going to decide. Okay. So and finally outputs are D0, D1, D2, D3. And here another we have, that is the enable. So already we have seen in the digital electronics what is the role of the enables. So we have active low enable, active high enables. So this enables value is either 0 or 1, how it is going to control the operation of the decoder. So on the basis of that here, this information, so when we have this D0, suppose for example, D0 output is active, then register R0 will be loaded with the contents of the bus, which contents is available at that time at the bus, that will be loaded to register. When D1 is the output here, then register R1 will be loaded. When D2 is the output here, then register R2 will be enabled and it will be loaded. When we have output D3, then register R3 will be loaded if information is available on the bus. So that which register is going to be loaded, that is being controlled by the output of the decoder. And if you are not going to use the bus, in place of that, we can have that is the three-state bus buffer. Okay, so it has two inputs here, one output. So this is the one input is A, another is the input is C. C is called as the control input, and A is the normal data inputs. So now here with the help of control inputs, we can generate the high impedance or low impedance at the output of the buffer. Okay, so buffer discussion also we have earlier in the digital electronics or digital logic design. So here what is going to happen if C equal to 1, then what will happen here? We'll have low impedance, and low impedance means A input will be transferred to the output. So output Y will be same as the A. And when C equal to 0, then output will have high impedance. So finally output of here that is going to be the 0, low states. Okay. So whenever C equal to 1, okay, whenever if we want to transfer the information, then we'll have to make C equal to 1. Then only input data will be transferred to the output. Otherwise, it will have high impedance at the output, so no information will be transmitted. Another here you are seeing that example of that in place of how we have done earlier. So like this here also we have discussion. So here by the help of decoder, okay, it is not multiplexer. Here what we are, this is the decoder. So with the help of decoder again here, two inputs are there, S0, S1. So this is going to be select that which buffer is going to be active. That's why it's called as the select. And if we have another third input is also here, that is the enable inputs. So finally, if you see that when we have here 0, 0 combination, so finally output of the decoder 0 will be active, and finally this is going to be the one input to the control signals, and finally the contents of the register A will be transferred. Okay, so here similarly 0th bit of each register is connected first, so that will be transferred to the bus. So again here 1, so second buffer, 2, next buffer, and third again next buffer, like this all buffering that is being controlled with the help of decoder output. So here it is given examples. Okay, so simultaneously it's going to change 0, 1, 2, 3. So that is the A0, B0, C0, D0. That means 0th bit of each register is being transferred to the bus line. So like this process will takes place. Okay, so that is the in place of bus. That I mean in place of multiplexer, we can use the three-state buffer here with the help of decoder. Next, we have memory transfer. To understand the memory transfer, we must have to know what is the memory. So this discussion already have idea about memory. In case of digital electronics also we have seen. Okay. So memory, again we'll have RAM, ROM, RAM having types, static, dynamic, again ROM having type, mask, PROM, EPROM, EEPROM. Like this, we have different types that you are aware of this. So when we are going to use any system, so if you see that speed of your system, either it is mobile, laptop, tab, anything, so that depends upon the RAM capacity. If RAM having high capacity, your system will be fast. And RAM is also called as the volatile memory. So here we have memory that is being used as the RAM is can be thought as the sequential circuits containing some number of registers. So we have in digital electronics generally we're talking about combinational circuits and sequential circuits. So sequential circuits means this output depends upon the present input as well as past output, so that it must have some memory. So this registers which is there in the RAM, so already we have seen earlier in the separate lecture is there for the register and register transfer language. So there you understand the importance of the registers, and those registers is made up of flip-flops, and you know that each flip-flop is capable to store 1 bit of information, and that is the age trigger. Flip-flops are age trigger device. So these registers are going to hold some bits and how many capacity is there. So how many combination of, you know that a combination of 4 bit is the one nibble, combination of 8 bits is the 1 byte. If register having capacity of 8 bits, then it can hold the information of 1 byte. So each of the R register is indicated by address. So each and every specific register having some address. So that address is very important here. Later we'll see that how we are going to write the address and how we are going to decide the capacity of the memory, everything we are going to see. So here this address, if each of the R register, if number of registers are R, then this address range will be 0 to R minus 1, since counting start always from the 0. So suppose we have 4 registers. So 4 registers are there, means address range will be what? 0 to 3. So 0 will be first, 1, 2, 3 like this, okay? And each register can hold n bits of data that we call as the word, okay? Its size can be 4, its size can be 8, 16, all these things. So now here we are considering that if RAM contents are equal to 2k words, okay? So finally, what are the structures required? So we required here n data input lines and data outputs lines also, that you can see in the diagram also. Data inputs n, data outputs also n, and we required k address line. Okay, how many address line? K address line. And here we have to perform the read and write operation. So we have read line and write line is there. Whenever you are going to store some information on the memory, then we have to perform the write. When you're trying to retrieve some information from the memory, that we have to read operation. Okay. So here later we'll discuss more in detail how we'll decide the size, and on the basis of that we can write the memory address and all these things. Okay. So next here we have finally memory transfer. So that how we are going to transfer the information. So for that here important thing is the address. Okay. So that address, so for that register is required that's going to hold that address. That is called as the address register. Any doubt is there? You can write in the comment, okay? So collectively, memory is viewed at the register level as the device. Okay, that is called as the M here. So it's constant the multiple locations. So each locations must have given the unique address. Like in case of society also, different peoples are, so many peoples are living. So each house having some particular number, street having some number. If you are going to reach the particular city, in particular locality you have to find. So first you'll go to the local area, then you'll find the road number, then you'll find the sector, then you'll find the house number. Like these are the combinations we have in the address registers. So that is done with the help of indexing the memory reference. So memory is being accessed by the computer system by putting the desired address in the special registers. So that particular registers, later we'll talk about again program counter and all these things later, okay? So here we have a special registers that is going to hold the register, having a special register that is going to hold what? Going to hold the address of the particular location in the memory. So that's why it's also called as memory address register, or simply we can call as the address register. So when we are trying to access the memory, so that contents of the MR get sent to the memory unit address line. Okay, so that here like we have address registers. This address register is transfer. So finally memory unit come to know that they are looking for which address. So what will be the contents of that address that will be transfer. So in case of read operation, first we have to give the enable the read, then we have to send the address of that location, then we'll obtain the data. Whereas to perform the write operation, again here first we have to enable the first we have to give the address of memory in which place we are trying to store the information. That location address should be given by the address register. Okay, and then we'll enable the write operation. Then finally we are able to store the data at particular location. That location is assigned by the address register. Now separately we can see how we are going to perform the read and write operation. So read a value from the location in the memory that will be loaded where? In the registers, and the register transfer we have different notation of the language that we have seen in case of RTL also. RTA is also very important question. So this causes the flowing to occur. So finally what will be going to happen here? The contents of memory address registers get into the memory address line. And if you have read is enabled, then it will be sent to the memory unit. If read is not enabled, then it will not transfer the information to the memory units. The contents of the specified address are put on the memory output data lines. Here we'll have data bus also. And this will be sent over to the bus to be loaded into the register R1. So finally, those things is being summarized here. First, we have memory address registers for the particular location. Once the read is the enable, then this contents of the particular address will be transferred to the data register. Whereas in case of write operation, to write the value from the register to particular location in the memory, we have to look for the register transfer language. Since we are going to, our contents is where it is stored in the register. Temporarily now it is where? In register. From that register we have to transfer into the memory for the permanent storage. So how this phenomena is going to occur? So that contents of the memory address registers get sent to the memory address line. So now here at which location we are trying to store the information, that location address is given to the address line. If write is being enabled, then it is being sent to the memory unit. And the value in register R1 gets sent over the bus to the data input lines of the memory. So later we'll have more discussion, data bus, address bus, control bus, all these things. So here address should be specified to the address line by the help of memory address registers. Then write should be enabled. Then only information of R1 will be sent to the data bus, and finally it will be given to the memory. And this value get loaded into the specified address. That address is given by the memory address register. So finally here this R1 is transferred to the particular address in the memory. So like this, we are able to perform the read and write operation. So finally here we are going to summarize that complete things what we have seen, bus transfer and the memory transfer. If any doubt is there, okay, keep on writing in the comment box. And if you have some personal inquiry, that also we can write. Your suggestions are always welcome. Subscribe, like our channel. So here transfer from the one register to another register, B to A. Okay. And again here that particular transfer the contents of particular portion of the register into the register AR. So it is in the DR data registers, we can transfer to the particular address register. And some constant value also can be transferred here. And again, if contents of the register R1 can be transferred to the bus, that bus is given as the A at the same time. Again, contents of the bus A can be transferred to the register R2. AR shows the address register, DR shows the data registers, M for the memory, M inside the bracket R shows that particular memory word by the particular register R. And in place of writing M of AR, we can write the M also. So from this transfer is memory to data register, and this is data register to the memory. So memory to data register means read operation. Data register to memory means write operation. So these are things here we have. Okay. So any doubt, please feel free to write in the comment. Okay. Thank you. Thank you very much.